In this module, we will be looking at how an A320 pilot and the aircraft computers interface to ensure safe and accurate flight with minimum workload for the crew. For clarity in this module, most references will be made to manual flight inputs. However, the references apply equally to automatic flight unless stated otherwise. A side stick or an autopilot sends a message to the flight control computers demanding an aircraft maneuver. The flight control computers process the demand and send it to the control surfaces. The processing uses preset limitations and instructions called laws. The aircraft responds conventionally to the movement of control surfaces. Normal law is modified depending on the phase of flight. It operates in 3 modes. Ground mode operates on the ground when the aircraft is electrically and hydraulically powered. Controls are conventional. Flight mode operates in the air after a gradual transition from ground mode just after liftoff. This will be discussed in detail as this module continues. Flare mode modifies the flight mode to introduce a conventional feel to the landing phase. This will be discussed later in this module. We will compare a conventional aircraft, an A310, with the fly-by-wire A320 in normal law or flight mode. Control surface deflection is directly proportional to control yoke deflection. The same yoke input produces a higher rate of pitch roll at high speed, lower rate of pitch roll at low speed. Control surface deflection is not directly proportional to side stick deflection. A side stick deflection gives a rate demand to the flight control computers. The flight control computers set control surface deflection to meet the rate demand. For the same side stick input, the control surface deflections will be large at low speed, small at high speed. A side stick input is a rate of roll demand in roll, load factor G demand in pitch. Yaw control is conventional. Remember, the A320 responds conventionally to the movement of control surfaces. However, unconventionally, the response information is fed back to the flight control computers. The computers process this feedback and adjust control surface deflection to ensure that the maneuver rate demand is executed accurately. This means that control surface deflections may be altered with no change in side stick position. In flight mode, if you wish to execute, for example, a descending left turn, you set the required attitude and then return the side stick to neutral. The neutral side stick position demands 0 rates of pitch and roll. The flight control computers will maintain the set attitude until you use the side stick to demand an attitude change. Throughout the maneuver, there are no pilot trim inputs. Turn coordination and Dutch roll damping are automatically provided in normal law. Pilot inputs on the rudder pedals are not required. Normal law provides a number of airborne pitch protections. They are load factor limitation, pitch attitude protection, high angle of attack protection, and speed protection. In lateral control, there is only one protection which is for bank angle. Let's take a closer look at these protections. In a conventional aircraft, pilots must ensure that structural limitations are not exceeded. However, in the A320 family, load factor limitation is available in normal law. Load factor limitation prevents structural overstress by limiting control surface deflections through the flight control computers. Full side stick movement is always available. The structural limitations vary with configuration. In clean configuration, between plus 2.5 G to minus 1 G, flaps extended between plus 2 G to 0 G. As with the load factor limitation, if the aircraft reaches the pitch attitude protection nose up limits, then the flight control computers will override pilot demands and keep the aircraft within the safe flight limits. The pitch attitude protection limits are shown as small green dashes on the PFD. Note that the pitch up values vary depending on the aircraft configuration and speed, between 30 and 20 degrees up. In the nose down case, the computers will limit the nose down attitude at 15 degrees. The high angle of attack protection is designed to prevent the aircraft from stalling and to ensure optimum performance in extreme maneuvers such as wind shear or GPWS warning recovery. This protection takes priority over all others. This protection displays information on the PFD speed scale. As speed decreases, it reaches VLS, lowest selectable speed with autothrust engaged. With autothrust inoperative or not engaged, the speed can reduce to the first level of angle of attack protection, the alpha protection, which is shown as the top of the amber black band, barber pole. With stick released, the flight control computers will maintain the speed at V alpha protection. If engaged, the autopilot will disconnect. Provided the autothrust is serviceable, the speed is unlikely to reduce to V alpha max before the alpha floor protection is triggered. This is indicated by an alpha floor indication on the PFD FMA and also on the engine warning display. If the pilots override V alpha protection using the side stick, the speed can reduce to V alpha max. In normal law, the flight control computers will maintain V alpha max even if a pilot holds a side stick fully aft. Nose up pitch trim is inhibited. In the protection range, the normal law demand is modified and side stick input is an angle of attack demand instead of a load factor demand. If the pilot releases the side stick at V alpha max, the speed will return to and maintain V alpha protection. The protection we will look at now is the high-speed protection. It is designed to prevent the aircraft from exceeding maximum speed. These protection limits are displayed on the PFD speed scale. VMO-MMO is shown as the bottom of the red-black barber pole. Green dashes indicate the speed at which the protection is activated. When the airspeed Mach increases above VMO-MMO, an overspeed ECAM warning is triggered, as shown in the autoflight chapter. If the airspeed Mach increases to the protection activation speed, the autopilot will disengage and the flight control computers send a pitch up command to the control surfaces to prevent further acceleration. The flight control computers will permit momentary exceedance of this speed for maneuvering if necessary. With stick released, the speed will return to VMO/MMO. Notice that the pilot cannot override the automatic pitch up. Under normal law, bank angle protection limits the angle of bank to 67 degrees, shown by green dashes on the PFD. If the pilot holds full lateral side stick, the angle of bank will increase and maintain 67 degrees. The flight director, FD, on the PFD will disappear if the angle of bank exceeds 45 degrees. If the side stick is released at any time when the bank angle exceeds 33 degrees, the aircraft will return to and maintain 33 degrees bank angle. The FD will be displayed again on the PFD when the angle of bank reduces to less than 45 degrees. Auto trim is inhibited above 33 degrees. With the angle of attack protections active, the bank angle is limited to 45 degrees and no further, if the pilot holds full lateral side stick deflection. With the high speed protection active, the system maintains a positive spiral stability to 0 degree bank angle, so that if the side stick is released, the aircraft returns to wings level. The bank angle limit is also reduced from 67 to 45 degrees.